Yeah,
Okay,
it is.
from now on, we are doing the recording.
Yes, absolutely good. Excellent. Bernd, it's obvious that we go to the same tailor. We have the same dresswear consultant. Excellent. It's 4:06. Indeed, yes. Okay, shall we start then? Right. Okay. So welcome everybody to the opening session of the central event of European Robotics Week 2021. This afternoon we are in Bologna, as you can see behind me. Bologna, a historic city, capital of the Emilia-Romagna region of northern Italy. And according to my extensive research on Wikipedia, Bologna is known as the fat, the red, and the learned city. Fat because of the richness of its food, red because of the roof tiles, and learned because of its university. And you'll hear more about the historic nature of the university as we go along this evening. So we can all dream that we are in Bologna, and some of our guests today are in the physical Bologna. Many are somewhere else in Italy or in Europe or even across the world maybe, but that's just geography, and in a certain sense today geography doesn't matter at the moment. Since the start of the pandemic, we've become accustomed to connecting with people online. So we may be physically separated, but today in spirit, we are all in Italy, we are all in virtual Bologna. My name is Steve Doswell, and on behalf of euRobotics, I will introduce our guests and keep this event moving for the next 2 hours. So, just some housekeeping tips. I don't have to tell you about the emergency exit this evening or the fire alarm. If you hear a fire alarm, then you need to leave your own building, but it won't be because of us at euRobotics here today. I just need to ask you though that if you are not a speaker, then please switch off your camera if it's not already switched off, and also your microphone. We are currently recording this session, so just please be aware of that, because we want to give other people an opportunity to see this opening session at a later point. So finally, we invite you to enjoy the presentations and just sit back and listen to our guests. And speaking of which, let me introduce our first guest. So Dr. Bernd Liepert, president of euRobotics, and for almost 30 years until 2019, Bernd worked for the robotic manufacturer KUKA, first as mathematician and developer, and then as head of development of the newly founded company KUKA Robotica until 1997. He joined the board of management and became CEO of KUKA Robotica, and then became Chief Technology Officer of the whole KUKA Group, and later Chief Innovation Officer for the KUKA Group, applying his vast robotics experience at the interface between technology and the market. He's also president of EUROP, the European Robotics Technology Platform, and subsequently president of euRobotics, the European Robotics Association. And this is a role that he holds to the present day. As president of these associations, Bernd has been a leader of the European robotics community and its representative at high political levels. In July 2019, Bernd founded his own company, Bernd Liepert, More About Robots. So without further ado, welcome, Bernd.
Thank you very much, Steve, for the introduction. Dear roboticists, dear ladies and gentlemen, thank you very much for attending the opening session of the European Robotics Week 2021. The week, now in its 11th year, was set up to bring robotics research and development closer to the public. Since then, and every year, the URW has offered 1 week of various robotics related activities across Europe for the general public, highlighting the growing importance of robotics in a wide variety of application areas and the growing importance of skills in STEM, which means science, technology, engineering, and math. Education and public awareness of what robotics technology, or more generally science and technology, can offer is more important than ever. In recent times, we also talk about STEM, which adds the arts to the purely technical fields. This means that, for instance, design principles and more generally creative elements are added to science and technology education. This concept would lead to an early consideration of usability and acceptance aspects in a creative development process, can make even school projects more interesting, and has the potential to attract larger groups of students. The public image, the appreciation of science and technological developments vary in different countries. There is some uncertainty in several segments of the population whether robotics, especially in the combination with AI, would lead to undesirable effects and unacceptable risk for people. However, improved safety at home, at the workplace, or on the road can be made possible with the right level of education and acceptance of latest technology. This clearly shows how important the outreach to the public is, and we cannot start early enough to show the state of the art and the next generation of robots to children and young people, so that their natural curiosity can lead to a deeper understanding and own thinking about what is technically possible and what is wanted and needed by free and prosper societies. I believe that that is a basis for considering a career in a related field. However, this year, outreach is again a challenge. We are now in the second year where the URW central event is held in a virtual forum, the second year that is affected by the COVID pandemic, where many events that would require access to hardware, be it educational robots for school classes or lab tours in research institutions or industry, cannot take place in the form it was done 2 years ago. But even if the event is virtual, I'm pleased that the University of Bologna was willing to be the host of the central event. The University of Bologna is said to be the oldest university, at least in Europe. It's remarkable that it's accepted women from the beginning on, with the first woman to earn a university degree and teach at the university back in the 13th century, and the first woman to have both a doctorate in science and a paid position as a university professor in the 18th century. It's a pity that the current situation did not make a physical meeting in this historical environment possible, but nowadays it's easy to see each other even when distributed over the world. Virtual events are therefore also an opportunity to have easier access without the need to travel or to limit a group size, while on the other hand, robotics is a science where the embodiment aspects are critical. For that, access to robotics hardware is needed. Hands-on experience is important to get a deeper understanding of the complexity of real systems, in contrast to poor simulation, which can be seen as a powerful tool, but with limitations. The current push of IT and AI needs to be complemented by mechatronics and hardware-related content. Besides the need to deal with hardware, we can also look at the opportunities that were revealed by the COVID situation. The community learned a lot about the offers and challenges of virtual events, and we should use that experience to develop new formats for the future, for example, by making hybrid events, for example, in a lab tour where people in the lab can actually interact with a robot and people distributed around Europe can see how it works. These ideas are also related to the question how the robotic community can be further built and strengthened. A medical paper showed that in times of distress, crisis, or disaster, human resilience depends on the richness and strength of social connections, as well as on active engagement in groups and communities, for example, like euRobotics. The URW, with all the activities, the central event, and the many distributed events across Europe, can contribute to bring all people interested in European robotics closer together, and I'm very glad to be part of this active and engaged community. We can be proud of this community. When asking the question, who is building the best mechatronic systems? The answer is clearly Europe. We are in the pole position and we need to keep this. Coming back to the URW. Besides the central event, there are still a good number of distributed events, even though the number cannot be compared to the ones before the pandemic. However, people started thinking about how events can be made possible, and we are looking to modern format, including hybrid and virtual activities, and hope that this is taken up during the central event of the URW next year in 2022, where the call for hosts will be published soon. But now we have to focus on Bologna, which is not only a beautiful city, but it's also the location of the SciRoc competition in September this year. The mentioned hands-on spirit that is core to robotics is best visible at robotics competitions that attract people to compete and to watch. Competitions are a perfect way to showcase developments and to give an outlook on potential future applications. The learning curve at such competitions is very high, as several teams deal with the same challenges in the same environment. At least for robotics competitions, the atmosphere is very friendly, and despite the fact that all teams want to win, there is a good exchange about different approaches, do's and don'ts, which lead to the fast adoption of the best practice. Therefore, we are very glad to welcome Professor Daniele Nardi from the University of Rome, La Sapienza, and Professor Valentina Presutti from University of Bologna, who will give a presentation about the SciRoc competition later on. Before that, we will have inspiring talks by Fiorella Operto, Scuola di Robotica, and I thought by Bruno Siciliano. Unfortunately, he is not able to make it today. I would also like to invite you to attend the session on Wednesday, again, 1600 till 1800, where not only 3 winning teams of an Italian robotic competition will present, but also a session on drones and one on education, innovation, on sustainability and industry will be held. At the URW activities at the central event, as well as the activities and events across Europe, will help to present a realistic picture of technology in contrast to expectations set by science fiction movies. I would like to thank all speakers of the opening today and the session on Wednesday, and the people behind the organization of the URW central event, especially Alessandro Machelli, Associate Professor at the local host of the URW 21, the University of Bologna. Thank you very much, and I wish us all good discussions and that we reach out to the public so that the inspiring field of robotics is seen as a highly attractive area to work in. I'm happy to play an active role in times of technical, economic, and societal challenges with a European perspective through the association euRobotics. Right, but now I will hand back to Steve, who will lead us through the day. Thanks a lot.
Excellent. Thank you very much, Bernd. That was very interesting. Very good way to start our opening session today. So I would now like to introduce someone who will give us a very good sense of location, as well as being thoroughly connected to the world of robotics. Alessandro Machelli took the laureate degree cum laude and PhD in automatic control and operational research at the University of Bologna in 2000-2003 respectively. He's been visiting scholar at the University of Twente in 2001 and postdoc 2003. In 2004, he got a postdoc position at Bologna. 2005, became assistant professor in robotics and industrial automation. Currently, he serves as associate editor for the IEEE Transactions on Automatic Control and for IEEE Transactions on Control Systems Technology. There is a lot more to Alessandro's career in robotics, but today for us, he is in a certain sense Mr. Bologna and will tell us something about the city as well. So please welcome Alessandro Machelli.
Thank you very much. Thank you for the incredibly good presentation. I know a little bit about that. So I hope you can hear me. Usually it works. So I have the responsibility of tell you something about University of Bologna, my university. And okay, I have a few slides that present the main features. And okay, let me see if I can share the screen. Okay, here I am. So I'm more a team guy, so that's why with Zoom I'm a bit out of my comfort zone, let's say. So okay, talking something about University of Bologna, and yeah, as people said, this is the oldest university in the Western world. So it was founded in 1088, so more than 900 years ago, and originally it was a law school, and the main feature was that it was independent from the church, which was quite something revolutionary for that time. And so it started as a law school, and then of course it has a long history, several milestones. Bernd presented some of them, so about women. So the first female woman that got the degree, got the Dini. We have an hospital now in Bologna named to her, and the other lady that took the PhD got a professorship position at the same level of men in the 18th century. Laura Bassi, we have a school on her name. And then more recently, Bologna is famous because in 1988, the directors, 500 deans of the university along Europe, they meet in Bologna and sign the Magna Carta Universitatum. So just to confirm the value and autonomy of the university. And then 10 years later, they signed the Bologna Declaration that basically created the standard of equality in higher education in Europe. So it's important. I think most of you have learned about this Bologna process. So it's basically, and then we have the picture. It's a historical picture about this 1999 meeting that we had in the main square of the city, and which is, by the way, brilliantly pictured by the background that we saw in the presentation. So, okay, so for the structure, Bologna is a multi-campus university. So it's quite unusual in Italy because we have a large campus which is spread all over Emilia-Romagna. So of course the main center is in Bologna, but we have other 4 satellite university in Romagna, so Ravenna, Forlì, Cesena, Rimini, and all of them are devoted to very specific courses. I'm not going into details of that. And we have other 4 important external, let's say, campus that are in Brussels, New York, Buenos Aires, and Shanghai. Personally, I taught 1 year and a half in Shanghai. So so we have a presence also in foreign countries, which is very interesting. So we start to be a very international university, and it is organized in 5 schools. So we are basically covering most of the, let's say, high-level courses, so it's starting from art, economics, management, engineering, medicine, and sciences. And all these schools, let's say, group 32 departments. So it's a very big university. It's one of the biggest that we have in Italy. And as far as the students, so we have a large number of students, around almost 90,000 students, and let's say that the number is increasing over the years, and in particular, it's also increasing the number of international students, so around 7,000, so which are not. It's quite start to be a quite large number. So I'm talking about the students that are enrolled in regular courses. And so you see this, the student distribution and in the satellite university in Romagna, and so we have basically 20,000 students that are not centered in Bologna. And we are also the first university in Italy for the number of international students that are coming from for Erasmus programs. So more than 2,000 students every year are coming to Bologna, and their number is increasing a lot. So in particular in the last years. So when I was a student, I studied in Bologna. Erasmus students coming from abroad were very rare, I have to say. Now they are starting to be very, very popular. So we have a lot of them, which is very nice. And of course, a lot of students from Bologna are leaving for Erasmus programs to other European countries. So the number of them is around 3,000, so which are a lot of students, I have to say. As far as the human research is concerned, so just to give you an idea of the staff, the teaching staff, the permanent staff is around 2,900 persons, and the technical staff is not reported here. It's more or less the same size, and it is divided in the way that is reported here. So we have a lot of colleagues, I would say, and in the last years, starting in 2018, we got a lot of new positions. So the number of permanent staff is increased a lot in the last year. So together with the, let's say, the number of students. So that's very important thing, I have to say. And what is nice, and is something that I would like to point out, and also the university is very proud about that. Okay, we are not reaching the 50% plus and 50% of balance between men and women, but we are reaching that goal. And so the teaching staff is 60% composed by men and 40% by women, and we are getting very close to the balance. That's what so the university is very focused on this goal. And okay, as far as the technical administrative staff, we have much more women than men, I have to say. Another important aspect, so much talking about education, so it's very nice because we have a lot of degrees programs, so more than 230, and among them 84 international programs, so which is quite a lot, and this explains why we have a large number of students that are enrolled and they come from abroad, and 47 of them are taught in English. And some of them are giving the double degree. So I'm teaching, for example, in automation degree, master degree in automation, and which is in English, and we give the double degree. So because we can, for example, attend the part of the courses here in Italy and part in Shanghai. So we get the double degree with the Tonji University. And we can do the same also at the laureate degree. So the laureate degree, so the bachelor, let's say, we have 3 years that are divided. Let's say the students have the possibility also to attend courses in Shanghai and get the bachelor degree either in Bologna and in Shanghai. And it is a very successful initiative that is more than 10 years that we have that. So I taught in that program too a lot of time ago. It was very interesting, I have to say. Also, okay, in the last years, the university focused a lot on PhD. We have 48 PhD program with a lot of PhD students, so more than 1,500 students. So a PhD program lasts 3 years in Italy. So every 2 years we have more than 500 doctors that graduate in this program. And if you look on the program Google searching for images, there is in the last years we got this nice habit to do the graduation, the official graduation in the main square of the city, just to connect, let's say, this advanced level of education with the city, and to show what are the results of this, the presence of the university in the city, which is quite integrated, I have to say. So it's very nice. As far as the research is concerned, of course, the university is very big, so it's focusing, I would say, most of the topics in which we can do research. Here, you see the list of the 13 thematic groups in which university is involved. You start from agri-food, biotechnology, climate, energy, and so on. Of course, robotics, which is the part of the research I'm doing, is inside the, let's say, information and communication technologies. And the department in which I'm in is doing a lot of research in this item, and also other one for agri-food, the biotechnologies, and so on. So it's we are doing a lot of research, high-level research, I would say. And okay, that's not a measure, I would say, for evaluating research, but is somehow a hint just to look at the European projects and European foundings. If you look at the Horizon 2020 funding scheme, we got more than 120 million euro in the last years. So it's a lot of projects. Here you have all the statistics over there. So basically more than 300 projects and 2,600 partners that are involved in this kind of initiatives. And also the other, let's say, important, but let's say from only point of view less dominant, but life science and so on. So it's a lot of research, and also the department, I mean it's very well founded involved in these European project activities. Also at the national level, but okay, just to give you, and what is important, there was a competition, let's say, between university and departments in Italy, and the University of Bologna got more than 100 million euros from the national government because 14 departments of the university were evaluated as excellent in their own fields of research, and in particular also my department, so the Department of Electrical Engineering and Information Technology, got some amount of money to perform some projects on, in our case, on cyber physical systems, with some part in agricultural robotics. That was very interesting. So I hope I gave you a nice overview, let's say, of my university, and it's a pity that you cannot come here for this event to visit the city and see how the university is well integrated with the city. It's a very nice city to visit, and I hope you can come in the future. And I don't know if there are students attending this presentation or young researchers. I hope you can find the possibility to come to Bologna for your courses or to perform your period abroad for researches. And of course, Bologna is a very warm city that welcomes the students since the Middle Ages, and of course we are very pleased to have you all here. So, thank you very much.
Okay, Alessandro, thank you very much. I think we now have a sense of the university, its marvelous history and its contribution to learning, and we also now have a sense of Bologna, the city itself. And we would like to take you up on your invitation to come to the city at some future point, once the pandemic is over, perhaps. Okay, so let's move on. Next, I'm very pleased to introduce Fiorella Operto. Fiorella, someone who I know because of her long-term associations with European Robotics Week, taking part in our national coordinators forums over a number of years. But in career terms, Fiorella has for a long time been associated with the Scuola di Robotica, the School of Robotics based in Genoa. She's a member of the board of directors of the School of Robotics and is currently vice president, which is a role that she took after 10 years as president of the School of Robotics. Fiorella has long been interested in and also contributed to thinking about ethical, legal and societal issues in advanced robotics and also in robotics education too. She's also passionate about teaching maths and physics to girls, which she's done on a voluntary basis over a number of years. I'm always interested in what people do outside, beyond their career sector. In Fiorella's case, she was also vice president of Passato e Futuro, an association devoted to the study and research on Italian immigration to the United States. So, without further ado, please welcome Fiorella Operto.
Thank you so much. I don't know if you see my slides. If you
Yes, we can. We can
okay.
Indeed.
Okay, thank you so much for inviting me. I'm very happy, especially because this time, after a so dramatic year, I think that we managed to survive a decline in many items, and that we can go on using robotics to solve the problem of today. I would like to start showing you the Italian landscape in robotics, reminding you that Italy during the Renaissance was the location where the term mechanics and mechanical lost its, let's bad connotation of a dirty work without any knowledge. And especially due to the work of inspired souls like Filippo Brunelleschi, Piccolomini, and especially Galileo Galilei, the idea of mechanics develop in a science. You see here a book by a roboticist called Mark Rosheim, an American one, who discovered that Leonardo da Vinci was designing already at that time robots, certainly not with electrical power and degree of freedom like today, but he imagined already the possibility of substituting human by machine. The other genius who worked on mechanics was Galileo Galilei, and he had this brilliant and ingenious idea of using machines to discover the law of the universe. And what I thought that was really an ingenious idea was the conception that by a machine, the telescope, you could intervene on the outer space, on the space. The legacy, the Italian legacy on robotics continues with one of the first robotic island you see on your left, the Sigma, one of the first robotics machine produced by Olivetti in 1974, and was what was introduced by Professor Meccarelli and Dr. Liepert about Europe is precisely the spirit of putting together science in theoretical physics and theoretical engineering with machine, which I like very much. I like the idea of putting together laws and practical intervention. Excuse me. To go now to the situation today, I would like to show some data from the World Robotics IFR World Robotics report, as commented by SIRI. SIRI is the Italian Society for Robotics and Automation. And you see that Italy maintains, and you will see also in the next slide, maintains a very fair sixth place in the gigantic power of robotics: China, Japan, Korea, United States, and Germany. And the distribution of industrial robots, I am speaking here about industrial robots mainly because we have sure and true data, while on other robotics data are less reliable. But you see that already you have a picture of the Italian place in robotics panorama. The density of robots per unit is also interesting. And you see that it's growing in the years, especially because of the increasing in the workforce cost and the need to substitute intelligent machines, substitute humans by intelligent machines. Again, you see that in 2020, Italy was stuck on this level after 2 dramatic years, especially this year. Not the 2020 was even worse, and because of the decline in consumption, difficulty in getting to raw materials, etc. But anyway, the situation remained quite steady. And you see again, the distribution of industrial robots in 2020 remained steady. Professor Bruno Siciliano will not be here, but he would have expressed, you know, the happiness about the fact that the brilliant situation of research in Italy, also in the cooperative and collaborative robotics. Not only a new association was founded 2 years ago to give intelligence, artificial intelligence, a body. It's called IRIM. It's the Italian Institute for Robotics and Intelligent Machines. But we have an incredible, interesting landscape of research in university and private centers, also in companies, that is producing prototypes and also is using robots purchased from abroad to integrate, to incorporate in the Italian industrial companies. This is the main activity in robotics, industrial robotics in Italy, especially since the main automotive company left Italy, Fiat, and we have a panorama of medium to little companies. This is one issue of the Italian panorama. In a sense, it's certainly a negative situation, a negative factor. But on the other hand, this is also what it's the reality of Italy, you know, many regions with different characteristics, and a long position from the north to Africa. This diversity, which is strange and could be a negative factor, was developed in a positive factor, because in Italy, you know, this panorama of medium to little companies allowed robotics and roboticists to be more close to the end user and to be able to integrate, to adapt cobots, mobile robots, ground robots, drone, etc., to the specific needs of these companies. And this is also important for education, as you will see. The other interesting characteristic of the Italian landscape in robotics is an excellence in design. You see here a Giugiaro car, designed by car. But more broadly, you know, what Professor Siciliano would have told you is that this art, this characteristic of artistic design in robotics is not only important for the shield, you know, for the external expression of the robot, but for the internal architecture and for human-robot interaction. I mean that by art, we should imagine that the end user is really cared about, you know, the external shape of the robot and also the function. And as I said, this diversity, that it's a necessity, you know, a negative factor, has been used and turned into a positive factor. Now, issues. I would like to talk about few issues that can be shared by many nations in Europe, because except Germany and maybe France for other elements, all the other nations are I think, on the same level of Italy in terms of lack of big companies, you know, that you have in the United States, China, and Japan. That means that in Italy, there are fewer than 5,000 companies with more than 500 employees, and especially located in the northern Italy. So that means that you have a south that lack, you know, industrial companies, and also that, you know, the feature and the cut of the companies are too small to allow for an internal career and an internal educational process. And in fact, as in many other European nations, now there is a lack of basic digital skills. Now the European Commission is calling for the Grand Coalition and other actions, because Europe lacks employees and workforce with e-skills employee, you know, and there is a general skill mismatch. There are competencies in fields that are not needed in professional, and the other competencies are lacking. Now, I don't know why. Okay. That's why educational robotics is so important today. Because you can use educational robotics for many important applications, from early education to refresh and update the professional knowledge of mature workers. Why? Because with educational robotics, you have not only, all the coding side, the programming knowledge to be learned, but you have physical objects. And this part of having physical objects makes students or mature students vis-a-vis in front of the law of natures. And again, I come from a philosophical background, not from an engineering background. My father was an engineer. I decided that I had to go to philosophy because I couldn't challenge my father. But I love science, especially physics. And I saw in many, many cases, the fact that if you have a physical machines, then you are put on the ground, your feet are on the ground. You have to deal with not only these laws, of the virtual coding, but also with the law of the universe, gravity, gravitation, etc., etc. This together, gives any student a very good emotional education, because not only you have this characteristic of sharing the error with the robot, because it's not only always your fault, but also the robots, they have bugs, they do not understand the environment. If light changes, they go berserk, But you have also a companion, with which you share the knowledge. That's why School of Robotics started in 1999, 2000. Courses on educational robotics when people said robot what, and now you have classes of educational robotics almost all over the world, contests, etc., etc. What we say is the sooner the better. Start early childhood education in robotics. And again, because the robotics need to uplift your teamwork capacity. So you work together with others. You promote girls. School of Robotics was the center of the Roberta Girls Meet, Robots Meet Girls, launched by the Fraunhofer EAIs in Bonn. Because by robotics, you can split robotics in many slices, and you can use these slices to teach physics, math, chemistry, anything, even language, even philosophy, history, anything. And you can add robotics vertically, so on along all the grades, and horizontal along all the subjects, And you have these challenges, I will shortly talk now, that are important because competition, it's not competition, among students or girls and boys. Competition is almost a game, They do not. It's not like when you're full of rage because you lose. On the contrary, they learn that losing it's the best way to learn. Now, the Italian ministry declared coding and educational robotics fundamental tools for teaching innovation. And the National Program for Digital School supported many schools, to get money and funding for kits, robotic kits. And now we have 100 schools from primary to high school involved in projects funded by the European Regional Development Fund. This European Robotics Week central event is devoted to contests. Now, contests are so funny, and I would just mention 3 contests School of Robotics is involved. The Now Challenge, it will become a humanoids challenge next year. And it's organized by the School of Robotics in cooperation with SoftBank Robotics and Campus Store. Now, what it's interesting is that in the now challenge is mainly you have mainly teams from technical institutes. So we said, okay, you are mad with technicalities. Okay, let's reverse and let's challenge you. So for 2 years, the Now Challenge was devoted to use this humanoid to promote cultural heritage. So you have a monument, you have a museum that it's abandoned or less known than others. Okay, think about how to use robotics to promote, to make known, and also to protect this cultural heritage. Okay. The ministry, Italian Ministry of Education, funded the National Robotic Contest along the 2030 Agenda 2030, and we won the call for the 4th years. The national, it's called Olimpiadi in Italian. We cannot use the same English word, but let's say a robotic contest for ground, air, and underwater, water, surface robots. And again, this year will be on health robotics. And then we have this first Lego League, you know, maybe it's all over the world. And in first Lego League, you have kids, kids really from 4 or 5 years to high school. I really, I urge you to open a robotics contest, you know, especially for girls. They are so good in programming. They're so devoted to use robotics for, you know, for project with others and for others, that you will be surprised by their ingenuity. Thank you.
Excellent. Sorry, you caught me by surprise there when you finished so quickly. That was really fascinating, Fiorella. Thank you very much indeed for that. There's so much. There's so much to think through and unpick. And I'm just grateful that we have a recording of today's session so that I can go back through it again and pick out some key themes as well. Now that was very good indeed. Thank you. Okay, so. Well, we are well into our opening session now, and we've already had some very rich content from some very engaging speakers. And I expect no different from our next speaker. So we will move straight on to introduce him. Professor Gianluca Palli from the University of Bologna, Associate Professor at the Department of Electrical, Electronic and Information Engineering, where he also received his master's and doctorate in automation engineering. He's active in the field of design and control of manipulation systems for deformable objects, anthropomorphic hands for service robotics, and grippers for both industrial and service applications. And there's much more besides. At the beginning of this session, I did say that I'm also interested in what people do outside of their professional kind of career sector. And I did notice that among images that appear on Google when I looked up Gianluca, I found some pictures of running and trail running, and I believe that Gianluca, you have somewhat of a secondary career in trail running, if that's correct. If there was time on another location and we were together in Bologna, I'm a keen runner and I would speak to you about that. But we're not here to talk about trail running. We are here to talk about robotics. So without further ado, please welcome Gianluca Palli. Gianluca, you're on mute at the moment. I can't hear you at the moment. No, we seem to have a sound problem. Okay, so I think Gianluca may be reconnecting. Yeah, still on mute. Sometimes it's enough just to see people, but I guess in this case we would like to hear from Gianluca as well. So as we've heard today, that unfortunately one of our speakers today, Professor Bruno Siciliano, was unable at short notice to join us, which is a great pity. But I'm sure that we've had plenty of rich content to receive and think through today already. One thing that Bruno Siciliano is known for is a certain expression, which was keep the gradient, which has become a bit of a slogan, meaning in research, keep looking for new ideas and new solutions. And I mentioned running before. Keep the gradient means something to me as a runner. You have to keep going and keep going. And we are doing our best to keep going with our opening session here this afternoon. I hope that Gianluca will be able to reconnect and join us. It is frustrating, I know, when the technology doesn't work. Aha! Excellent. Yes, we can certainly hear you now, Gianluca.
Okay. Yes. Sorry for this. Let's say, took my laptop because from the fixed workstation I was not able to make the microphone work.
No problem.
Okay. So can I share my screen right now?
Please do. Please go ahead.
Okay. So great. Okay. So sorry for this technical problem. I suppose you can see my screen.
Not yet.
Not yet. Yeah. Great. Okay.
It's coming. Excellent. Yes, there we are.
Good. So, sorry again. So, thank you for your introduction. Yeah, I had, let's say, second career as a trail runner, but let's say, I stopped my career a couple of years ago when my small daughter were born, because now I'm very busy with her. So, but in any case. Yeah, in this presentation, I would like to introduce you the activities related to robotics we developed here in the University of Bologna, in particular at the Laboratory of Automation and Robotics. So this activity is not only let's say my activity, but also, it is developed by Professor Melchiori and Professor Marconi, that are, let's say, the seniors in this field. So our area of expertise are in particular in the field of control and design of robotic manipulators and prostheses, telemanipulation, haptic and wearable devices, but also mobile area and field robotics included underwater robotics. So, okay, I will start showing you some results in the field of prosthesis. We basically applied several techniques that we developed to drive our robotic hands that are based on acquisition and classification of EMG signals by means of machine learning techniques. We developed these activities for the control of robotic hands, but then we also exported these results in the field of prosthesis, in particular for fall detection, because we realized in our studies that one of the main issues to enable the users of prostheses to rely really on them, so to be confident with them, is to make this able to detect when a failure is occurring in the execution of a task. So when the prosthesis for some reason is not able to accomplish the activity. And also together with the studies we made on the kind of feedback we can provide to the users, we were able to demonstrate the capabilities of making this user more capable of executing activities of daily living, like grasping cups and making many others tasks. Then we apply similar techniques also in the field of wearable devices. So in this picture, you can see, and also in this video, wearable device based on twisted string actuation we developed to support users in different kind of activities like lifting loads. So here in this video, you can see how this system can be used to reduce to a minimum level the effort of the user while supporting loads, and also this can be applied for rehabilitation, but also to support workers in many different activities. And we also designed the robot and the wearable robot, and we are also extending this in other fields like teleoperated systems to provide active feedback, force feedback about the activities executed by a robot in external environments. This principle are also applied to robots, in particular collaborative robots, in which we show how we can increase the capabilities of the conventional kinesthetic teaching, so the capability of driving collaborative robot in space to teach some sort of task. And by using EMG signals, we were able to use these robots for different tasks to support the activity of the user, or in general to increase the information related to the trajectories, for example, the stiffness information, and also the need of precision in certain regions along the execution of the trajectory of the robot. And this also is by means of EMG signal, the feedback provided by the muscle activation of the user while teaching the task to the robot. Okay, another relevant application field in which we are active are industrial activities. And in particular, I'm the coordinator of an European project called Remodel, in which the main objective is to deal with a problem that is particularly relevant in industry. So the equation is when you have many variants in a product, you have a product in which the shape is unpredictable, and this is the case when you work with deformable objects like cables or clothes, and you have to perform complex manipulation with these objects. This results in manual operation or manual assembly in industry. So in this project, we target some of these tasks, in particular in the field of cabling, wiring harness manufacturing, but also the wiring harness installation in the automotive field, that are all activities that are nowadays performed manually by workers because of these issues. So the main objective in this project is to put together all the experience that users have in this field, also all the information that we can get from the design of the products, and by means of artificial intelligence algorithms and also specific tools from the point of view of the manipulation system and also the manual capabilities of the robotic platforms, to use this to generate semi-finished products, so to carry on at least all the repetitive activities, because in all these tasks there are activities that change from time to time because for example, the objects have unpredictable shape, but the kind of task is always the same. For example, you have to fix a cable into a certain point, or you have to connect two components with a cable. So these activities are quite repeatable, and so we target these activities in order to make robots to make it able to work on this. So in this video, you can see one of the platforms that we developed. So basically here we have a manually assembled and cable switch gear, and the robot is used to perform connection testing. So the robot is equipped with one camera. So the robot is composed by two arms. We have a camera in both the end effector, and we basically, with this camera, we can locate the components where they are, because the position of these components is not perfectly known, because the components are assembled by hand, so they are not in a well-defined position. And the robot is then able to check all the connections that are executed by the humans in order to verify the quality. So it's a quality test. And of course, to make a robot able to make this test autonomously and independently from external input. So this test is performed just on the basis of the design of the product. It's very important because it allows to save a lot of time in the production and validation of this product. So next step will be to also deal with the manipulation of cables to execute the connection. Of course, the platform is not still ready for the use in the industrial production, but we are basically at the middle of the project, and we will be working on, and we will work on this to put this to a more higher technology readiness level. To deal with the location of the components, but also the manipulation of cables to execute connection, we develop a lot of tools based on artificial intelligence. And we combine different kind of algorithms like semi-automatic labeling, component detection based on 2D vision, and so on, to solve the issues that we have. For example, in this video, I collected, okay, I can remove the audio. We collected some of the tools we used. For example, we used the tactile sensor to locate the cables. We also use vision to locate the cables when they are not in contact. We use classifiers to check the grasping is performed in the right way. And we also use tactile sensors to be able to detect when the task is executed in the right way. So in this sequence, for example, we evaluated what happened if we perform the task correctly or not. In the, say, bad case, we made this artificially to evaluate the capabilities. We also developed tools for the semi-automatic labeling of components. That means the robot is able to understand by itself and train itself by having approximate information about the initial position of an object in order to save a lot of time in the training of the system, and also increasing the accuracy. Then we developed suitable tools, and we adopt these tools to perform demonstration of the capabilities of connecting cables into electromechanical components. And this will be the base to complete also the connection phase, that is what we are doing right now in the remote project. I will skip some part of the video just to save some time. Okay, this here, it's an accelerated sequence in which we see how the robot is able to fix some piece of cable into these components. Okay. We worked a lot also in reconstructing the shape of cables, that are basically the main objects we are working with. Again, using a lot of artificial intelligence in our algorithm. So our basically the main challenge is to make the robot able to interpret what is looking to. So the shape of the cable, the shape of objects, because these are not defined. So we have to interpret every time the scene in order to be able to decide to perform the task correctly. We also applied this technique to create a three-dimensional reconstruction of the environment. So in this case, okay, I would like to accelerate this a bit. You can see the robot scanning the object. So we have a switch gear with some cable attached, and by means of some scanning maneuvers, so here we skip a bit. Here the task is executed a bit faster. Then the robot is able to create a scene that is very similar to the real one. There's a comparison between the real scene and an artificial scene that is reconstructed on the base of the scanning. We also apply this technique to very challenging objects, like these are very thin medical catheters. This material is pretty transparent to, for example, 3D vision sensors that make this very challenging to be detected. So we use 2D scanning and chip 2D sensors to detect the shape of these objects. And in particular, we use this also to perform grasp attempts in order to see that we are able to locate the object in space. And then we also demonstrate the capabilities of tracking the object shape, so we can move along the profile of the object without touching it, basically. Then we have also a more challenging case. This is a thinner object, and also with a thinner hole, let's say. So we are able to follow the profile of the object without touching it. Okay, next slide. Then again, by means of artificial intelligence algorithms, we are able to define a manipulation sequence in order to achieve a desired shape of our deformable objects. So in particular, the robot is programmed just to grasp and release the object on the plane, and by analyzing the scene and comparing the scene with the desired result, we are able to define a set of manipulation sequence and manipulation activities that makes the robot able to reach the final shape. And we also demonstrated that this sequence is optimal. So in this video, we just show this result. So we start with a straight rope in this case, and we would like to achieve this S shape at the end. So the robot look at the scene, decide which is the maneuver to be performed, and move the object accordingly in order to achieve a shape that fits up to a certain precision with the desired configuration that we would like to have at the end. So of course the scene is reinterpreted at every manipulation step. So one objective is to make this manipulation sequence the shortest possible to optimize the task. Okay, this is basically a different case in which we start with this S shape, and we would like to achieve a straight configuration. So the robot autonomously define which is the sequence. So you see in the first action, the robot tried to make let's say elongate the object in one direction to stretch it. And finally, okay, up to a certain precision, this was the final result that is similar to the target. Okay. Then we apply this method also to not only to cables, but also to planar deformable objects like clothes. This is this result also won an award. Sorry, I remove the audio. This is the team. Okay, it's not only my work, but also two PhD students work on that. And here in this case, okay, this is a summary of what we have seen before, another task in which we manipulate cables by means of our robots. And then we apply similar strategies. This is the rope manipulation to the manipulation of clothes. So we have two robots doing laundry, basically. So putting clothes into a washing machine. This is an activity that, okay, I can skip this part of the video, of course. Instead of doing this task by hand, we'd like to make this to be made by a robot. Okay, so our this is our setup in which we have a robot equipped with vision that is able to perform the segmentation of the scene. It means it is able to interpret the objects. So there's a bin or a container in which we have clothes, and we detect wrinkles in this clothes by means of the analysis or filtering of the images provided by the vision sensor, and we basically find these wrinkles can be exploited like the shape of a cable in order to manipulate the clothes, in order to perform optical grasping, and then execute the task of manipulating, picking objects and put them inside the washing machine. So we tested this algorithm with different kind of clothes, and we were quite successful. We also recently improved this success rate by merging different techniques in doing this task. And here you can see the robot executing this task in different conditions. Also, in case we have clothes hanging on the door of the washing machine. So basically, this kind of filtering is applied in different ways and different conditions. Okay. Last activity is related to recent results in the field of robots for agriculture. So our team developed this field robot that is applied in an experimental orchard that we have here in our university. And this robot is able to autonomously navigate into the orchard. And okay, these are also videos showing the final demonstration we had in the field with the robot navigating autonomously, reaching the plants basically, and navigating through them by autonomous navigation, looking at the path and distributing, in this case, the kind of treatment that is required for this particular culture. So here you can see how the robot is able to move autonomously into this plant. Then we are also working to make some sort of teleoperation for precise maneuvers, also extend this robot providing capabilities of manipulation in order to also provide harvesting capabilities, basically. That's it from my for my presentation. I hope you enjoyed them. Okay, now open to questions.
Okay, well, Gianluca, thank you very much indeed for that very interesting presentation. It's taken us into some fresh territory for this particular opening session, and we're very grateful for that, and equally for having brought forward your presentation to help us solve a gap in our agenda today. So thank you for that. We do have a couple of minutes for questions, if there are any questions for Gianluca. If you do have any questions, those of you who are with us this afternoon, then please open your microphone and your camera and feel free to ask. So we're looking around. And people are either they're completely and thoroughly informed and satisfied with what you had to say, or they're being a bit shy this afternoon. Okay, well, it looks like you've got a free pass there, Gianluca. Okay, well, in that case,
thank you for your invitation.
Yes, indeed, indeed. We're very grateful for your joining us today. Excellent, thank you very much. Okay, so I shall move on. I assume that our two final presenters are here. Yes, I've just seen a message. Marvelous. Okay, let me introduce them. So, now to bring our Bologna story up to date from being at the site of the oldest university in the Western world to the venue of this year's SciRoc competition. Incidentally, I know that in the English-speaking world, the competition is often known as SciRoc. Our Italian colleagues pronounce it SciRoc, which also sounds like the Scirocco wind, which blows with force and drama from the mountains into the sea. So drama is in keeping with a competition, and we are the guests of our friends and colleagues in Italy. So it's the SciRoc competition today. So here to introduce SciRoc and talk us through it are Professor Daniele Nardi of the Sapienza University in Rome, and who is also and has been president of the RoboCup Federation since 2011. Is currently faculty coordinator for student exchange, referent for the master curriculum in AI and robotics, and teaching the course AI for several years. He leads the research laboratory cognitive robot teams addressing a whole range of different research topics. Among his many research papers authored and co-authored, one title caught my eye: Coordination and Cooperation in Robot Soccer. So soccer, here we are back in competition territory. But before we hand over to Daniele and Valentina, let me introduce very briefly Valentina herself. Professor Valentina Presutti, researcher at the Semantic Technology Laboratory of the National Research Council in Rome. She received her doctorate in computer science here in Bologna, the real Bologna, in fact, and she's been the scientific coordinator for CNR in the EU-funded project IKS, Interactive Knowledge Stack, a framework for semantic CMS that brings semantics to the interaction level. Among many other accolades and career experiences, she is editor-in-chief of the ontologydesignpatterns.org initiative, and she has co-founded the series of workshops on ontology patterns. So without further ado, over to Daniele and Valentina.
Thank you, Steve, for your nice introduction. So let me share the screen. Okay, I hope you see the presentation.
Yes, we can. Yes, we can.
Okay, so this is a joint presentation because it's reporting about a really joint effort. And I'll start by, thanking Valentina for undertaking this joint efforts. And actually, the two of us will, on my side, I will present the project view. SciRoc is a coordinated action funded by the EU. And the goal of SciRoc is to develop competitions in the context of smart cities. And in particular, we are trying to do the following. focusing on the competition, let's say with the as in many previous cases of EU-based competitions of, let's say, supported by our coordinated action in full. While at the second stage, we opened up our competition and we created a bid. And Bologna was the winner of the bid, and Valentina was the winner of the bid. And this is how we got this second smart city competition we are going to report upon right now. Okay, so just a quick mention of the first competition, which was held in Milton Keynes and in September 2019. It's before COVID. And so the competition was in a big shopping mall with lots of visitors. In a very nice environment. For that competition, we have envisaged a number of challenges that we have called episodes, and some of them have been transferred to the competition in Bologna. But before I address the specific type of the setup of the competition, I really want to highlight briefly, these are pictures again from Milton Keynes. And you see students and colleagues working at the robot, is that we had in this coordinated action, we had this open process with an initial call that was answered by several expressions of interest. Then we distributed the bidding package, and in the big bidding package with instructions on what is needed for a competition. And then we had a selection because we had 3 full applications. And this is particularly rewarding to us because it's a sign that the competition can, at least to some extent, be self-sustainable, meaning there are many cities that stand up and offer to host the competition, where there is, of course, a significant effort involved in terms of the hosting city, but eventually there is also a substantial reward in terms of visibility, relation with the citizenship, and so on and so forth. So the bottom line here is that there is really space for organizing this kind of event and get support from cities. Okay, so that's the selection criteria were relatively straightforward in a sense, but I want to say here that Bologna really did fulfill all these criteria very well, at best, I would say. So Bologna will be described by Valentina. Let me go through the episodes, the technical part of our competition. The first episode is serving, essentially is based on the task of serving items in a coffee shop. So the robot should go through the table, check whether there are customers, eventually take the order and serve the order at the table. Now, the point, the technical point of this competition, in addition to the challenge of developing a full-fledged robotic system to accomplish the task, was that we had no clue at the time we were organizing whether it would have been possible at all to do the competition in presence. So we had to prepare, and we had to prepare to face different possible scenarios, which ranged from the one scenario where everything was fully online to the one scenario where we could eventually go to Bologna and have the competition in presence. So we ended up with lots of developments that would help us to deal with all this range of situations. In particular, and these are the 2 novelties that I would like to highlight in terms of the competition, we had a fully simulated environment, which was some sort of digital twin of the real environment. And in this simulated environment, we also simulated human-robot interaction. In other words, the simulation environment was designed in such a way that it would, the robot could get the face of the person through the camera of the computer where that was being used by the virtual customer, and also the audio coming from the customer itself. And the second thing is that we had on the Tiago robot by Palli Robotics, we had a special deal with Palli Robotics, which was a major sponsor of the event from the point of view of the SciRoc consortium. And we were able to run the code which was developed remotely after, downloading it and running on the code on the robot on site. And I think this is really what should eventually happen in the future, but this is still at the moment sort of very advanced. I don't want to say science fiction, but in order to have a robot deployed in a specific environment, there is a lot of tuning and testing going on, which we managed to handle with this remote participation. The second episode was about a very specific kind of interaction, which is the interaction through the sign language. And here you see one example of sign language. And, I would like you to guess what is this sign. And after, if I tell you, I'm sure that you will realize that this could mean gelato. Anyways, this is no joke. The sign language is a full-fledged language, and we were able to build a data set for the expression and gesture recognition systems that had to decode those signs and to interpret correctly those signs. And plus, the signs were defined in the small vocabulary. Actually, the sign language is really a complex language, and it was a discovery. And the challenge was not only to correctly interpret the signs, but also to play the signs. And here you see one example of a signs played by the Tiago. This was done at the competition. You see, we were in a very beautiful location. It is already apparent from this. And this sign means there is no coffee. Actually, I should show you the sign played by a person. But in fact, this is going to be maybe not, we don't have enough time to go into the details. Anyways, this episode was really exciting because not only because of the technical part, but because of the involvement of the deaf people community. They were contacted since the very beginning. We designed together the challenge. They contributed to define the language. The language had to be simplified because the Tiago robot has only one arm. So there has been some adaptation of the sign to the one arm only robot. And they have been really into this project, and they are asking us to continue on and to do it at the level which is going to be much more, much deeper than what we've been able to do in these months. There are a few other episodes. I'm going to skip all these videos. Okay, the third video is the shopping cart. The third episode is the shopping cart. For this shopping cart, we do have a collaboration with the Eurobench project. And in fact, the setting, which was developed by Politecnico di Milano and Sapienza University of Rome, the setup is going to be one transferred in one of the two experimental sites that have been set up through the Eurobench project. And then we have developed, we in Sapienza have developed the simulation part. And in Milan, they did the real thing. This cart that can be, it's a typical supermarket cart where the forces that are given to the car can be measured and reported as a feedback to the robot, so that eventually the robot learns or can learn how to gently push a cart or a trolley or some other device on wheels of this kind. So this was the third challenge that we have designed. Then we have emergency delivery. In this case, the challenge was not possible with the drones. Rather, we had the challenge on site, where the robot had to explore the environment and report the presence of a certain target. And then we had the final episode, which is about detecting and placing items on a shelf. And in this case, we experienced also a different type of competition, with remote teams participating by performing the challenge at their own sites. So the performance was then available through video, and the evaluation of the performance was done in Bologna. So in the end, we had a complete mixture of online and in presence for a competition. And this was, I think, a great success on our side. I do believe that the model has brought about several technical issues that we've been able to handle, which may lead to robots that are much better prepared for action in an environment, in a remote environment. And in addition, it's been trying to fill in the gap between simulation and real robots. So on the technical side, we are quite happy. You see here the simulator, which is a gazebo simulator for the coffee shop episode. And here you see the real thing, where the robot is moving in the background and is executing the task. This is essentially what I wanted to say in terms of the achievements that we have been obtaining in technical terms from this competition, which I think they are really remarkable, given the situation. We've been able to, let's say, put together and create new models for the execution of the competition that combine remote and online. But all the effort for the organization and preparation and success of the competition is up to Valentina, and I am very happy to announce her presentation to come next. Okay, thank you very much. One final word. I mentioned that we had a special agreement with PAL, and that's also a word of thanks that I want to add to this to close my presentation. So Valentina, I am stopping the sharing and the floor is yours.
Thanks, Daniele. Thanks, Steve, for the introduction. And let me share the screen. Okay. And this. Can you see? No.
Yes, we can see it.
Yep. See this one. Better, right? So now you see the right one, I guess. So thanks, Daniele. And actually, it's not true that it was all my effort, because actually the group of Daniele and the consortium really had a big part and role in the organization. And so Daniele already explained the process. I just wanted to say that the motivation why we decided to do the bid, to submit the bid, we were really intrigued by the fact that SciRoc addresses puts in place the idea of creating a connection between citizens, the general public, and the robotics competition, which also has a relevance for the scientific community. And this for a city like Bologna, but I guess for many others, is powerful for showing the commitment and the engagement of the cities as a smart city. So we partner, and the consortium, the SciRoc consortium, partner with us. We had also Fondazione Innovazione Urbana and Fondazione Alma Mater. These are two foundations, local foundations, which work, which are participated by the University of Bologna, but also by the municipality, and who helped in taking care of the communication, the logistics, the administration, financial issues, and also supporting with for the fundraising. And thanks to the involvement, indirect, let's say, involvement of the municipality of Bologna, we had the possibility to run the competition and the event in a really special and iconic venue, which is in the core of the city center. It's a symbol for the city, and it's Palazzo Renzo. And also we had the availability of Cortile del Pozzo, which is a place very close to it, like a few steps, where they organize lots of events for and where we had our public debate that I'll tell you in a moment. So this was, we used two rooms, two big rooms of Palazzo Renzo. This was the bigger one, Sala del Podestà, where we had 3 episodes. And the other one was this one, where we had the other 2 episodes. So just to give you an idea of the environment, which was really beautiful and I think inspiring for the teams which were there. Our idea, as Daniele already had mentioned and that we included in the bid, was to have a diffuse event. So to have the event spread in the city. So to give this idea, to simulate, let's say, to give the message that robots are around, so you can meet them around the city and they can help us and co-live with us in the city. And we actually had also the possibility, the availability of other 2 beautiful places. One is the Fondazione Golinelli and the room of the Bologna University Library. But we then took certain decisions because of the pandemic. So we didn't know if we were able to do this in presence, and it was unclear. And then we actually had the moderate confidence that this would happen in late spring this year. So it was really late. And this caused significant difficulties to the organization because potential local sponsors would not even discuss about the physical event. I mean, they had other priorities. So this impacted on the available budget. So the prediction that we could do on the available budget. And then when we started having some more certainty, then it was late for doing certain things, also because everything piled up. So you can imagine it was really not simple. It was hard, but of course we didn't give up, as you know. And we decided, however, to run the competition in one place, so we could reduce the cost, so we could focus on the important things and simplify the logistics. And we secured the funds for the local administration and technical support and for the streaming services, which was important given the fact that the event should go hybrid. And then we focused on organizing only one co-located event. You can imagine we had many ideas for doing workshops, symposia, but then we decided, okay, let's do one and let's focus on this and let's do it well. And also we recruited volunteers for addressing visitors and providing users for the episodes, for the evaluation. Nonetheless, we managed to have some sponsors and partners, which I really want to thank. And they were from some local companies working in automation and starting investing in also robotics and we had an important national communication partner, Sole 24 Ore. We had sponsor from academia, but also industry. And we had more than 20 volunteers, all brilliant researchers from the University of Bologna, which did a really great job. And they were recognizable because we created this official SciRoc T-shirt, a very nice T-shirt, and they were really, easy to spot. Daniele already explained that we had to plan a very special way. So we basically defined a new format for the robotic competition. And of course, these actions, the streaming and the remote participation, also revealed that it could be an opportunity for the future, not only a mitigation plan for the situation, the pandemic condition. So we had 21 expressions of interest from teams all around the world. The coffee shop was the most, let's say, required, probably because it's the most popular and running since long. But we had lots of expression interest. The sign language episode also raised a lot of interest. And in the end, 14 teams registered and participated. We had 6 teams participating from remote. Yeah, as you can see, we had mainly teams from Europe and the UK and one from Asia. We had around 700 visitors over the 3 days, that considering the situations of the restrictions, and we were probably one of the first events running in Italy in presence, because in Italy they started allowing in presence events in September, and we were running in early September, so it was still but we think it was a very good number, because the palace is you have to go and enter it. It's not like you go, like, for example, in the first edition, certainly they had many more visitors, but they were maybe passing by. Here we only had people who wanted to come to the event, so they actually went there on purpose to visit and attend the competition. And this was the timeline. So we had a couple of days to set up the whole thing, so the arenas and all the technical things, and the team starting rehearsing and setting all the technical equipment. And after an inaugural event that we had on Tuesday, the 7th of September, then we had 3 days of the competition. And on Friday, the last day, we had an awards ceremony, and then a public debate, which was really interesting, that we entitled Robots, Smart Cities and Inclusion, Researchers Meet Citizens. So this was how the palace looked like already 1 week before the event. So there was this huge banner, and this is the entrance. So I collected a few photos just to give you an idea, but already you saw also some videos. And so we had the five episodes and the award ceremony. So it was really also like very positive and nice. We were really all happy to be there. As you can imagine, it was one of the first experiences since a while. And the public debate at the Cortile del Pozzo with Olga Capirci, who is an expert, a researcher of the National Research Council working on sign languages. So for us, this episode, as Daniele already underlined, highlighted, was, one of the, they were all, of course, interesting, but this one was peculiar because it was one of the first attempts, and very challenging, and involving also the community of a community of deaf people who worked with us. So it was really challenging and inspiring. And Francesco Ferro from Robotics, together with me and Daniele. One important thing is that I didn't mention, but this was also related to the theme that we had for the whole event, which was smart inclusion. So this was also, this motivates also why, you know, the sign language episode was particularly important for this event, because our focus and the message we wanted to strongly give is that robots can actually also have a relevant role, a significant role in enabling more inclusive smart cities. So I would like to show you a video just to give you an idea of what was, you know, what was like to be there. So let me. Okay, I think you should also hear the audio. SciRoc is a robotic competition held this year in Bologna. There are 14 teams competing on 5 episodes. These episodes are scenarios where the robots have to demonstrate their capabilities to perform tasks that are socially useful. There is an episode which is, in my opinion, a particularly interesting one because it's the first time that we see something like that. And this is about the robot recognizing and also generating the sign language. So it is able to communicate with deaf people or ear impaired people.
Despite all the difficulties, COVID-19 and the restrictions that are related to COVID-19 have forced us to think new ways of organizing these robotic competitions. So here we have teams that are competing on site, which is the standard model. We have teams that compete in simulation. Then we have another mode for participation, which is that team deliver their code that we run on the robots here in Bologna. And this is really quite new and challenging because usually robots require a lot of tune-up and careful engineering of many things before they do perform on a site. We also have a model of the competition, which is a distributed model, where competitors run their robots at their site, and their performance is reproduced here through video, and it's evaluated here in Bologna.
It was really important for us to get to the organization of SciRoc, because this also is important for the city, for the local territory, to create a network with industries and researchers around the world. One of the main reasons to organize this event as an open event to the public is to create a closer connection between researchers and citizens. Okay, so let me close with a few reflections. So these were the highlights in a video, and so our let's say conclusions and also some lessons learned that may be useful for the next for the organization of next SciRoc, but I think in general for other similar events. First of all, I think that despite the pandemic, so I mean, we can say it was a successful event, but we are aware that we could not express and benefit from its full potential. So it went really, really well, and this actually tells us how it could go if we didn't have all these restrictions. And some reflections I collected. Is that being a competition, clearly the teams are very focused on their testing and a lot of there are lots of periods which apparently nothing happens, at least for a general public. They don't understand that something is actually happening, but they cannot see much. So I think that an event like this should have in its schedule activities that are designed for the general public, like workshops, presentations, demos, which may be not related to the competition directly. And also we opened at like 9 in the morning and then closed at 5:30 in the afternoon. We realized actually that many people that would come, they had to ask for permission for leaving the office. So maybe an event like this is better to start later and finish later, so you can get more people coming that maybe couldn't make it because it was office hours during the week. And also we couldn't do differently this time, but in general, for a possible next one, what I would do is to make sure that we run the event when schools are open, especially high school, and to make sure that to arrange on time agreements with high schools to have students visiting and participating in workshops. Another thing that I think it's crucial for SciRoc is to secure international regular sponsors that can provide a basic budget that so that you know that they are there and you make in kinds or cash, it doesn't matter, but that cover, let's say, the necessary aspects, so that you can build on top of it then by raising funds from the local sponsors. And another thing is that I think, so organizing an event such as SciRoc takes a lot of effort, but also you learn many things by doing it. And I think that this knowledge, this know-how that you develop should be reused to improve the format. So I think that an event like this shouldn't change location at every edition. It should have like 2 or 3 editions in the same location to grow and to improve the format and then to pass the knowledge to the next one. But also it's important for the local territory for benefit, really from, to maximize the benefit from the event. Many people, also the people from the local sponsors, talk to me about next time we can do this next time. So they want to build on the experience because new idea raised and so on. And then last thing is that I think there should be, so maybe to think about an agreement with several robotic companies that both make sure that they have a benefit from this, so that the being there as competitors doesn't harm their business and goals. On the contrary, that they can benefit from this, and also SciRoc would benefit from having different platforms that can be available for the teams. Okay, so thank you very much for your attention. These were my conclusions.
Excellent. Thank you very much indeed, Valentina, and indeed, Daniele. Well, you've all good competition should come to a climax at the end, and I think we've had exactly that experience with our event, our opening session this afternoon. So thank you for that. So it just remains for me to thank everyone who's taken part today, and particularly our speakers. So thank you to Bernd, to Alessandro, to Fiorella, to Gianluca, and not least to Daniele and Valentina, who brought this to a very fascinating close. Incidentally, I loved the interiors, the historic architecture that you were able to use, and I know that in my own country Milton Keynes has many qualities, but I'm not sure if architecture is one of them really. But anyway, leaving that to one side, thank you very much for getting European Robotics Week underway. As Bernd said at the beginning, we have another interesting session on Wednesday afternoon, so please do log in for that as well. All the details are on the euRobotics website. So it just remains to me to thank everyone once again. Thank you for giving us an opportunity to spend 2 hours in the atmosfera bolognese, perhaps to a certain extent. And I wish you all a very good evening. Thank you and goodbye.
Bye-bye.